Welcome back to this chapter where we're going to be looking at PairRDDs. Because it's very common to have two values in an RDD, we have the concept of a PairRDD. And this is going to allow us to store a so-called key and value. And the advantage of doing this is that we'll get extra methods in a PairRDD that are going to allow us to do operations such as grouping by key. And we're going to be doing quite a lot of that through this course. For this chapter, we'll change examples and do something a little bit more realistic. In fact, this example is something that is very, very commonly done using Apache Spark, and that is processing log files for busy servers. So imagine that we've managed to obtain terabytes of data from a web server. And it's in this very simple format. We have on the left-hand side the level of logging, so that could be a warning, an error, a fatal, or whatever. And then after a colon, we have the date and time that that log was produced. So very simple and straightforward. And the requirement for this chapter is we need to count up how many warnings there were, how many errors there were, and how many fatals there were, and so on. So before we go any further, we'll go into Eclipse and we'll get this test data set up and transferred into an RDD. So here's the code as I left it at the end of the last chapter. So again, we're going to use this basic Java collection to input our testing data. And this is going to change now into a list of strings. Either make up some data for yourself, or you can borrow my code from the sample solutions folder, or you can pause the video and just copy in what I have here. I'm not going to bore you by typing all of this out, so I will fast forward at this point. Great, that's our sample log file set up. Exactly as usual, we're going to use the parallelize method to read this data in. Before long, that's going to be coming from something like a Hadoop HDFS file system. And that's going to be stored in our starting RDD. The only change here, of course, will be now this is an RDD of strings, and I may as well change this to something like original log messages. And this line here, of course, is from a previous example. We don't need that anymore. So we've done the routine job of getting the data into an RDD. Now we need to think about how we could count up how many warnings there are, how many errors there are, and so on. Now, I don't think we really have quite enough theory. We haven't learnt enough yet to be able to handle this requirement, at least in an efficient way. Now, in order to count the number of warnings and the number of errors and so on, we're clearly going to need to split this file into two components. We need the level, the warning, the error, the fatal, or whatever, and we need to separate out this date and time into a separate field. It's no good having each line as a single string. Well, just going back to the previous chapter, you know now about tuples or tuples, commonly used in Scala, and therefore they're commonly used across the Spark API. So a first kind of plan of attack could be we could create a new RDD based on the original one. We're probably going to use the map method to achieve this. And we could create a new RDD containing these tuples. And the elements of the tuple, we'd have a string and a string. The first element could be the level, and the second element could be the date and time. And I suggest this is going to give us the flexibility to be able to somehow group the related levels together, and then we might be able to count them somehow. And you could absolutely try to do it this way. This looks like a reasonable plan of attack. But the problem is going to be when we've built this RDD, I'm not even sure how we're going to go about doing the counting here of how many warnings there are as opposed to how many errors and how many fatals there are. There's probably several different ways you could do it. You could maybe create a new RDD and where you just filter out the warnings, and a separate RDD containing the errors and a separate RDD containing the fatals. And then you could run a count just as we did in previous chapters. That would work, but okay, there's only sort of 5 or 6 different levels, I suppose. So that could be That could be a possible way of doing it, but it doesn't sound like a general solution, because if there were thousands of different types of message, then, well, that could become very unwieldy. So let me cut to the answer here. It turns out that this is such a common thing to do, to separate things out into two columns, if you like, that Spark features as a kind of core part of the API something called a PairRDD. And the idea of a PairRDD is it's an RDD with two, I'm going to say two columns. It's not really two columns, but you can visualize it as being a table with two columns. Now, in my example, the first column type is going to be a string, and the second column type is going to be a string, but you can probably guess that these two types can be any Java type that you like. And we commonly talk about these two columns as being the key and the value. And all I've done is I've set up this PairRDD so that the keys are the logging levels and the values is really just the rest of the stuff. For the moment, it's just the date and time, but there might be some other information that we might want to store in the value as well. Now, if you've never come across this before, you might be a little bit confused. I certainly was when I first used Spark. And the confusion would be, I would say, if you're a Java developer, the first thing you think of when you look at this is you think, well, this is very similar, if not identical, to a Java map. Of course, a map, fundamental Java collection storing key value pairs. But if you've had a good look at the caption, you'll spot that there is a really crucial difference in a PairRDD. Have you noticed that I've got here for a key, worn, and then some value, but I've used the key worn again here with a different value. It is a slightly different value. And we've got another warning here. So the keys are being repeated. And in Spark, that is absolutely fine. So I'm going to put a big warning up here to remind you, although it looks very much like a map in Java, in Spark we can have multiple instances of the same key. And that's very normal. In case you have a background in data structures, or if you've done computer science to any level, then you might recognize this structure as feeling more like a traditional bag structure, sometimes called a multiset. Now, in the standard Java API, there is no similar concept to what we have here. It's similar to a map, but with a crucial differentiation. There are some other libraries, such as Google's Guava, which does have the concept of a bag and would allow you to model this kind of structure. Anyway, what's important here is the fact we can do this in Spark, and it proves to be very useful indeed. You might be wondering why this is useful, because we could have almost got the same results just by having a regular RDD containing tuples. But the answer is, with a PairRDD, we have several extra methods that will allow us to do very rich operations against these keys. So I'm going to show you those operations, of course, in a few moments, but before then, I think we ought to switch to the code and see how we would initialize this PairRDD.